Hey guys, welcome. Yeah, so part four here, and remember that in part one I had said that sometimes on double and triple integrals, the order of integration may have a huge impact on whether or not the double integral or the triple integral is easy or hard to do. And here's a very good example of that situation arising, which is the double integral given is very hard to do as it's written, because the way that it's written, we have to integrate sine y squared, and we don't know how to integrate that. Sine y squared is not an elementary function. So we must change the limits of integration, we realize. So we want, instead of dy dx, we want dx dy. But since we want a number out of this double integral, we can't throw x to 1 over here. We have to be a bit more thoughtful about these limits of integration as we change this from dy dx to b dx dy. Now, the way that it's written, right, the region over which that we're integrating the surface sine of y squared is this region right here. By the way, the surface sine of y squared is right here, but we're only concerned about this surface that lies directly above this triangular portion, which is when sine y squared is confined to these limits, which is when y goes from x to 1 and then x goes from 0 to 1, right? Then we form this triangular region, and this triangular region would lie directly below this surface here in the xy plane, right? Okay, cool. So if we want dx dy, then what should be the limits for x? Well, the limits for x should be from x equals 0 to x equals y. So we're going to change these guys from x to 1 to from 0 to y. And then for y, we're going to have y go from 0 to 1. So this 0 to 1 is going to stay by coincidence, but inside we're going to change this to be 0 to y, and then of course we're going to change these guys to be sine of y squared dx dy instead of sine of y squared dy dx. Yeah? Okay, cool. If you do everything I just said, then this is what you'd have. And now, integrating with respect to x first, since sine of y squared is just a constant, we're going to get x times sine of y squared evaluated from 0 to y, and then outside of it, we're going to have 0 to 1 and then dy, right? Okay, but yeah, crucially, what I'm saying is, since we have to start with this inner integral, 0 to y sine of y squared dx, the integral 0 to y sine of y squared dx is going to be x times sine of y squared evaluated from 0 to y. Okay, cool. So doing that, we write this here, x times sine of y squared evaluated from 0 to y. Then, of course, as I said a little bit earlier, we have a dy there, and then 0 to 1. So a single integral. And I was going to say simple too. And now in the evaluation, clearly, we're going to replace this x here with that y. And then we're going to replace this x here with that 0 and take the difference. And if we do all that, we're going to be able to write this here. Cool. All right, now, what is the antiderivative of this guy is the next question. Well, we're integrating with respect to y here, and so we'll have this cosine of y squared times a half evaluated from 0 to 1, because what's the derivative of cosine of y squared? It's going to be cosine of y squared times 2y. And so here, the only thing missing is the 2 that should multiply this y, and we compensated by the half and then 0 to 1. If you were confused at this stage on how to do the integral from 0 to 1 of y times sine of y squared dy, then you could look at some basic substitution, also called U substitution videos, and that'd help you out. But otherwise, moving forward from here, it's pretty straightforward how we should finish. It's evaluating that we have left to do, and if we do it correctly, then we'll see that the final answer can be written as 1/2 times the quantity cosine of 1 minus 1. Yeah? Okay, cool. Of course, this one here in radians. All right, I hope you enjoyed this, and keep watching. Take care.